from Sir Nigel about how much he wishes he could have traveled into outer space. Well, our next guest here on Center Stage can tell Sir Nigel and the rest of us here exactly what we're missing. He has flown beyond our atmosphere, making history for his native Africa. And down on Earth, he continues to push the known boundaries of the cybersphere. And we are delighted that he has come today to tell us his story. So please help me welcome here to Center Stage the founder of Canoncial, Mr. Mark Shuttleworth. Good to have you here with us. Hey, it's right here. Yeah, there was this big talk today with Sir Nigel that he wished he could be an astronaut. What about having flown into outer space actually informs you as you try to change the cyber sphere?
I think a common story that every person who's had that perspective on life will share is just your sense of the interconnectedness of everything, all of our histories. When you have seen the Earth from some distance, you realize first just how close everything is, how closely interconnected our various cultures and countries are, and also just how fragile those systems are that we depend on. I was struck by how visible the footprint of man on the face of the Earth is when you see it from a distance. And people who've had the privilege of flying several times over many years say that they can actually see the progress of that, if you could call it progress. And so I think that makes anybody who's been in that situation just mindful of the sorts of projects that you take on after that. And you probably have a desire to do things that have a global impact in a constructive.
Yeah, you don't see boundaries
kind of
or borders maybe the way you did.
Not at all,
earlier.
no. And you get used to the idea that Morocco is 15-20 minutes away from Mozambique, right, when you're in orbit.
Right.
And at any given moment you might be over Japan or South America or Europe. So you just get a sense of the Earth as a whole.
We're going to talk a little bit more in just a few moments, but you came today also to talk to us.
Yeah, the organizers asked me to talk about game-changing technology, things that I think might be, game changers, profound shifts. And so I brought along three lightweight ideas. Two of them are things that I'm a kind of custodian of and personally interested in. And a third is an interesting set of developments in space technology.
Okay.
I'm happy to dive into that.
Okay, go ahead.
Right, hello everybody. My name is Mark Shuttleworth, and I currently lead a company called Canoncial. I lead the product strategy for that company, and that company makes Ubuntu, which is an operating system. But operating systems are kind of unusual things. They go everywhere, and in a sense they're invisible, because people, at the end of the day, they care about the thing that they're actually using. They care about the application, whether it's in the cloud, whether it's in the data center, whether it's on a mobile or on a PC. So that's a little bit of background as to the filter that I see the world through from a technology point of view. But it gives me fairly wide leeway because, operating systems do go everywhere. So a simple map of computing today. There are only three areas that are really interesting today from a computing point of view, in my eyes. The first is you and your personal computing, the sphere of computing around you. We used to call personal computing, the PC, but today obviously it's much richer. The second area is, and it's really the emerging area today, is things, stuff, all around us, all of this electronics, in your home, all of the electronics, in the warehouse, in an office, all of the electronics, are all becoming intelligent. What do we mean by intelligent? Not that you can have a conversation with them, but that they're able to interact with other systems, that all of these isolated pieces of electronics are becoming network devices and effectively becoming servers in their own right. And then, of course, there's the cloud. There's all of that computing out there. So I want to focus on two of these areas. Start with personal computing, what's happening around you. 5 years ago, 10 years ago, personal computing was the PC, the laptop. Today, we see personal computing as sort of an aura around the person, right? Your mobile is now perhaps the most personal computer. Tablets, PCs, television is becoming an aspect of personal computing because a lot of your digital life is playing out on the television. And of course, the wearable story is going to extend the solar system with new planets and new satellites, essentially, new devices that become part of that personal computing platform. Now, we see all of that as being aspects of a single real idea, which is your personal computing. And that's why we focused on trying to create a platform which can be inside all of those devices, but more interestingly, a platform which at any given instant can be any of those devices. Because where we think that the future is that the brains of this device will never leave your pocket. The brains of this device will sit inside your back pocket, or you'll carry them around somewhere on you. And what you'll take out of your pocket when you use the phone is just a screen and a microphone. What you'll use when you use a tablet is just a bigger screen. What you'll use when you want a PC experience, all driven by that thing in your back pocket, is a bigger screen, a mouse, and a keyboard. And there are all sorts of signs. You know, when you have a view like this, it'll take a decade to come. All right, so you start to look for the pieces falling into place. And here's an interesting picture for you. This is a real product. It's a phone from Asus, the Pad phone. It's a great little phone. The newest version of it is really quite slick. But that Pad phone, that phone, can become a tablet. You dock it to a bigger piece of glass, and suddenly you have a tablet. And of course, we all know that you can take a tablet and give it a keyboard and mouse, and suddenly you have a PC. So the first signs of this are in place already. Here's another interesting picture. This is a Google project. It was a project that Google took on board, and they placed it with Motorola. But interestingly, they didn't pass it on with the rest of Motorola to Lenovo. This is Phone Blocks, or Project Ara. And the idea here is to deconstruct that cell phone into pieces that you can replace as you need them. But what's interesting about that is that one of those pieces is the brain. And so again, we've already got the beginnings of the idea of saying, let's separate out the intelligence of your personal computing. So instead of having an intelligent PC or laptop and an intelligent phone and an intelligent tablet, maybe we'll just have a single intelligent personal computer which can take on the shape of any of those other forms of personal computing, can drive my augmented reality, can drive my watch notification system, earring, whatever wearable computing you happen to be into. So this is the first game-changing idea, a profound shift in the way people will think about personal computing. All of us are mindful of the fact that the smartphone was a disruption on personal computing. Our thesis is that it was not the last disruption, but that the next one will be essentially going beyond just the smartphone to the smart personal cloud of devices. So that takes me on to the next piece of really interesting technology today, which is in the data center. All data centers today are being reevaluated against a simple benchmark. Can they perform as efficiently as the largest data centers, the data centers that are being operated by Google and Microsoft and Amazon and Facebook? Those companies take a profoundly different approach to their core technology to your traditional data center. And in the end, all data centers will be benchmarked, and only those which can perform in the way that the major data centers perform will survive. So our perspective on cloud is very interesting. Ubuntu became very popular amongst developers, and so as a result of that, we're now the platform that is used most on those big clouds. So if you look inside Amazon or the Microsoft cloud or Rackspace HP or other clouds, Ubuntu is used on a majority of the workloads. A majority of what's running on Amazon or a majority of what's running on any of those will be on Ubuntu. So we have a visibility on what the developers needed to create that stuff that they're running on that environment. This is backed up by people who provide, for example, enterprise portals to those clouds, giving people a gateway to the clouds that gives them a management view of what's running on their cloud. They, of course, can see across all of their customers, across all of the enterprises, what's happening there. And these guys, for example, see us on 70% of the workloads that they're orchestrating on the clouds. And as a result, you can see a great deal of the innovation that's happening on cloud computing today is happening on Ubuntu. All of these brands, all of these platforms are things that are accelerating and easy to consume on Ubuntu on the cloud. We're also a platform that's being used to create clouds. So the big guys typically created their clouds using internal development. Today, what most people are doing is trying to create smaller clouds that still have a lot of the same properties. The way they're doing that typically is with either VMware as a proprietary virtualization platform that's growing a cloud layer on top of it, or with Linux, and the Linux of cloud is something called OpenStack, and most of the OpenStack deployments are also on Ubuntu. So I give you all of this as background on our perspective on cloud computing. You know, we're engaged with people who are building clouds, and we're engaged with people who are using clouds on top. And that perspective has given us a very interesting thought process. I'll skip over all of this. Thought process for us as to where the blockers are, what's challenging, what's slowing people down in cloud. This is a very nice quote from Deutsche Telekom here in Germany, building a small business solutions portal on a cloud backend, essentially, with Ubuntu. So what is slowing people down? If you think about cloud is all about moving more quickly. So the question then is, well, what are the remaining sources of friction? What are the things that would slow you down? And really, when you dig into it, it's all about complexity. And complexity is killing both halves of the cloud story, right? The supply half, where people are anxious to sell new services, new capabilities, and the consumption half, the buy side, where you have enterprises who very much want to be consuming things more quickly. And what's slowing them both down is complexity. If you're an enterprise with an IT shop, for you it takes time to integrate anything new, and that time has a cost associated with it. We're seeing an explosion in new things. So just in the last, buzzwords of the last year: Redis, Rabbit, Hive, Spark, Cloudera, Horton, Hadoop, Cloud Foundry. If you're an IT guy, this is driving you crazy, because there are so many things that are interesting. There are so many things that you sense are important, but it will take you time and cost a great deal to be able to get in and understand them and know how to integrate them, know how to create value out of them. If you're on the other side of the equation, it's even worse, right? If you're creator of one of those pieces, then it takes time to essentially get people to start getting value from your stuff. We work with both halves. We work with the large enterprises who are consuming goodness on the cloud. We also work with the startups, the guys who are trying to create new solutions, things that they can sell, capabilities that they can sell to those enterprises. And for them, this is a death march. They can create the technology very quickly, but it takes time to convince people to evaluate that technology. They then have to send their engineers on site and do an integration, and it takes time. All of that is eating up capital and diverting resources away from making the product itself better. So we studied that, and we asked ourselves, what are the common patterns? And in every startup, in every R&D office that we went, we saw pictures like this, whiteboards with people having pictures of what they would like to create. And on those whiteboards, you'd see boxes and lines, right? Stuff talking to other stuff. When you distill it down, all of these complex applications are a set of pieces of software that have to be installed on many, many servers, many pieces of software on many servers, and then they have to be hooked up and configured. And what makes it tricky is that you want to be able to do that dynamically. You want to be able to get more of it at short notice and less of it at equally short notice. But at heart, it is about connecting up and gluing together and integrating lots of pieces of commodity stuff. So what do people do with that? Well, another challenge is they have to do that integration 3 different times. They have to do it once for their developers. They have to do it once for any test infrastructure that they're doing, and then they have to do it again in production. So if you look at these machines, say you've got a team in the office of the CTO in a bank, they will take some time to spin up developers who are now becoming productive with a bunch of those buzzwords that I had up there, doing something notionally interesting. If that's interesting, they'll then have to set up a process where that can be tested so that they can do rapid rollouts. And if that work goes well, they then have to put that into production. So you've got all of this complexity, and you're dealing with change at multiple levels all of the time. So we asked ourselves, in that environment, since we have that visibility, what would magic look like? If you could step out and become like some alien from the future that could just show up and just say, look, I'm going to show you some magic that eases all of that. What would it look like? And we thought it would have 3 key properties. The first is it would be totally automated, right? It is people that introduce errors in these processes. Of course, you need people to create the stuff in the first place, but having people do the repetitive work is essentially just a recipe for getting things wrong 1 time in 100, which of course slows you down dramatically. It would reuse the same tooling and processes in those 3 different arenas: development, test, and production. And it would take as much of this from off-the-shelf commodity parts. We studied what we could of Google and Facebook and Amazon, and we realized that inside their environments, they try to have a totally automated solution, and they had achieved that. And they had this alignment between dev, test, and production. But for them, they couldn't consume anything off the shelf. So their infrastructure is very expensive to run because they need 10,000 people to create any piece of content that's going to go into that infrastructure. But if anybody could consume that capability from commodity parts off the shelf, well, then everybody could be like Google. Everybody could scale, and everybody could move more quickly. So we drew a picture. Essentially, we said, okay, well, let's take what we see on the whiteboard and make that into software. Let's let people create that. And with a little bit of luck, I want to demonstrate for you what the result of all of that looks and feels like. So here I have a blank canvas. That blank canvas could be on any cloud. It could be on a public cloud, or it could be on a private cloud. It could be on physical servers, or it could be on virtual servers. It could be on slices of servers. It can be on any architecture. It could be on x86 from Intel, from AMD, or it could be on ARM, racks of ARM servers, the same silicon that goes into these, but hundreds of thousands of them in racks, like HP's Project Moonshot. And what we want to show is that what would it be like in this magical world if you could just drag and drop software and deploy it in this cloud environment like that. What I'm doing, in fact, can be done live in production today. So what I've done is I've said to that cloud, give me some machines, spin up a database on the one of them, spin up an app server, a content management system on the other, and tell them that we want them to talk to each other. Since it's a cloud, those machines will arrive instantly or in seconds. Since we've created this kind of magic, the integration of those pieces of software will also happen instantly in a totally automated fashion. Don't have to log on to any of those servers. I don't even have to be able to log on to any of those servers. I can simply essentially paint the picture that I want to create. And since it's a cloud as well, I can scale it out. I can say, oh, what if I want this database to be running over 3 units? In other words, I want 3 servers providing that database. I can just ask for that, and abracadabra, magically, that integration happens. But this is still a bit painful because I've had to essentially do something that everybody knows they're going to do, right? If you're going to have a content management system, it's going to be a database. It's going to have a database. What if in fact all of the work of figuring out what needs to be connected to what if that could be provided in advance? So what if I could just go and say, look, I want to find something that does a whole bunch of things in one hit. Well, that might look like this. But what have I done? Magically, I've said, well, somebody else has created a pre-defined set of integrations of complex parts, and I want to reuse that whole, what we call bundle, in one hit. And so this tooling now is allowing us to work with startups who have complex pieces of software. Complex software today is many pieces of software across many machines. It's letting us take them into big enterprises, telcos, large integration shops, SIs. It's letting us help them show that their software does interesting things much, much faster. Instead of taking 6 weeks, 8 weeks, 12 weeks to do an integration and a proof of concept, they can do that in an afternoon. So I think this is a game changer because it drives value on both sides of the equation. This is all free software. This is all open source. There's nothing proprietary here. We're interested in this because the faster we can have people adopt cloud, the more they're going to use something like Ubuntu, which is a platform that works very well on the cloud. But what's fascinating for me about it is that I see how entrepreneurs, startups, and how IT guys light up when they see this, and they realize that that is now 15, 20, 50 servers within minutes up and running in production, ready to take data, ready to analyze data, ready to generate results. And when they realize that this picture can be modified live in real time, if they want to try a different management system, they just drag it in, integrate it, and immediately are able to see if it's working. So a profound game changer in terms of the way that back-end infrastructure works. Right. So, what about that third arena, the third area where I think there's game-changing stuff happening? Well, on the side, I have this amateur interest in space. I'm a space cadet in every sense. And you know, since the 1960s, we've had the same basic parts getting us into space, right? We've had liquid rocket engines, and the problem with two liquids is that they mix very easily. And if they have, if they're explosives, then mixing them makes for very, very big explosions, very impressive and very expensive explosions on the launch pad. So all of your liquid rockets, they generate a lot of thrust. They can be controlled very efficiently because you can turn up the rocket engine and turn it down, but they tend to explode. And when they do, it's a very violent, very dangerous, very expensive kind of explosion. The other kind of rocket engine we've had are solid rockets. The tragedy with solid rockets, in this case a real tragedy, is that you can't turn them off. Turning off a solid rocket is like trying to sort of stop a match head from burning once you've struck the match, right? There's nothing you can do. That match head will burn. Only after the match head's completely burnt out, can you perhaps blow out the match. The problem with socket engines, with solid rocket boosters, essentially, is that the fuels again are pre-mixed, and so once you light it, it will, you know, from ignition, it will keep burning until it's out. You can only use it once. You can only burn the whole thing at once, and that's it. Great if you have a very heavy object that you want to get into orbit. Not very good if you have things that you want to use in a more subtle kind of way. So what's the game changer? Well, two interesting new developments in hybrid approaches to rocketry. The first is hybrid solid liquid. So you've seen a lot of commentary about space tourism and the new generation of vehicles that would provide suborbital access to space. Well, they're all using this new approach to rocketry. And so what are they doing? They have solid fuel, but only one half of the fuels. The other half is a liquid or a gas. And so that provides a very interesting combination. They get all the properties of solid fuel. They get a very high thrust ratio, but they also get many of the benefits of liquid fuels because they can turn that rocket on and off. So that's why you'll see a lot of new things like the land speed record. The current challenges to the land speed record, they want to use this kind of rocket. All the suborbital access guys are using this kind of rocket. A much safer, much simpler, much more controllable way, potentially, to get us to space. There's another interesting concept, though, which is this one, which is to say, well, one of the challenges with rocket engines is that you have to carry both. You're carrying your oxidizer, essentially the thing that oxygen, and the thing that burns, you're carrying them both from the ground all the way up. What's silly about that is that most of your energy goes into getting out of the atmosphere, and the atmosphere is full of oxidizer, right? It's full of oxygen. So some very smart people are now working on being able to combine rocket and jet engines, and this is a project in which I have a very distant interest, but which is led by some really brilliant engineers in the UK and now increasingly in partnership with companies in Germany and France, to create hybrid jet and rocket engines that will essentially be able to fly in the atmosphere like planes and then switch into rocket mode out of the atmosphere, so that you could fly to the top of the atmosphere in what looks like an aeroplane, essentially take off from a runway, get to the top of the atmosphere, and then become a rocket and get to Australia in just 2 hours. So again, a game changer. At the end of the day, it's very interesting, you know, when we look back, these profound game changers, they look obvious. But at the time, they look anything but. And that's what I love about this field, right? That all around us, we have assumptions about what's possible. And those assumptions are breaking down every day. Thank you very much. I hope that was interesting. And Brent.
Any questions? Because we've got about 5 minutes left. Any questions from the audience? Anyone want to ask anything? I mean, there's a lot to digest here. The notion of the cloud for you. The cloud is everything to you right now, it sounds like.
The cloud is absolutely central to all the work that we're doing with industrial, large-scale computing. So, you know, any time you think of a data center or servers today, that is now shifting into a cloud mentality. The hardware is being designed around cloud infrastructure. Software is being re-engineered to work well in those scale-out kind of environments. A way of thinking that was pioneered by Google, but is now becoming standard for everybody.
I didn't hear you really say anything, though, about security and privacy, and obviously everyone's talking about that right now. What's your opinion about guaranteeing a maximum amount of security if so much is taking place now in the cloud?
I think security is fundamentally a question of practice. And I think experts would agree that there is nothing stopping you from being secure and adopting cloud technologies. You just have to have good practice in what you do and where you do it. You can build a cloud in a highly secure environment, keep information there which you want to segregate from everything else. You can use public cloud environments if your information is something that you can take a certain amount of, you have a certain tolerance for risk for. So security is really about practice. Privacy ultimately is about regulation. We will have no privacy in the absence of regulation. There are too many incentives for both us and the people that make stuff for us, right, to violate our own privacy. So we love using free software, right? And I don't mean open source. I mean software that's free, right? If there's a great saying that says that if you're not paying for the product, you are the product. What that really says is that your privacy, the violation of your privacy, is the business model.
Okay, right? If you're not paying for it.
Right, but we love it, right? We love all those free apps that you can download and use. And so fundamentally, in the absence of regulation, whether that regulation is focused on transparency and making it clear when your privacy is being violated, or simply enforcement and saying that it's not legal to violate people's privacy in certain ways. In the absence of that, you know, we have no real expectation. I have no real expectation of good privacy for the average person.
Okay, you don't expect that. We've got a tweet here: space flight and open source software. How come? I guess they're meaning, how do those two go together for you?
Well, what's great about open source is that you can have confidence that it's being used in a wide variety of applications, and there's a lot of visibility, and you can repurpose it to do whatever you want. I have a good friend who is into rocketry, and all of the control systems that he uses are open source. At a more industrial level, you know, a lot of the systems that control next generation rocketry are all being built on open source. Open source is at the heart of the vast majority of supercomputers today. It's at the vast majority of mobile phones, at the vast majority of embedded devices. So I don't think there's any reason to think that open source wouldn't be central to, space technology, one form or another. I was quite glad, though, that the capsule that we flew, the Russian capsule, the control panel on that was an 8-bit processor, which we had to program in Octal. It was from the 1970s, but that actually gave me a sort of warm, fuzzy feeling.
Why? You felt safe?
It was well debugged.
It was well
by
debugged.
the time we flew it. Yeah, it was 30 years old, and they'd probably found most of the bugs in it.
That's right. That's right. Talk to us a little bit about your phone project.
So there's not much point in doing something just like what other people have done. That's not interesting. There's usually a market for an also-ran, but we're about the third or fourth company to come up with a phone. So what's interesting for me about what we're doing is this convergence story, because it's profoundly new. The hardware that I showed you there was from Asus. They're trying to make it work with Android, and it's very challenging because Android wasn't designed or built with this idea of being all of those kinds of personal computing. We have the great luxury of starting late, so we were able to sort of think about that very deeply before we got going. And I think as people get more excited about the idea of having a personal computing device, which at any instant can be a phone, can be a tablet, can be a TV, can be driving wearable computing, can be a PC, then they'll appreciate the gem that we have at the heart of the Ubuntu mobile story. We have our first two manufacturers. I was very excited at MWC to announce. One great European company, BQ, a company that really understands how to insert itself, put the right device in the right hands. And then similarly in China, a company called Meizhu, sharp elbows, guerrilla operator, knows how to go into a crowded market and differentiate. So I think that's a great start for us, and I look forward to kind of building on that.
Who is going to be the user? Who will want your phone?
If you look at the way we segment the market, two groups. The first group that's extremely important for us is people who don't really want to be that fussed about their phone. They want something that's clean and beautiful, easy to use, and does all the basic things really well. That's something we can control. We can deliver something for that audience because we know the apps that they care about, we know the functionality they care about, and we can test the usability of Ubuntu against Android and iOS and Windows and other options. And there we do pretty well. We have a lot of bugs to fix, issues to address, but we will deliver a phone that's much more usable than Android for that audience. And then the other audience is the developer audience. These are guys who want something amazing. And the devices that we think are possible to create when you have convergence are extraordinary, right? You can develop once. From that phone, you can push your software to the cloud. You can target all these different form factors, phone, tablet, PC, TV. You can target them all. We will add wearables to the story. And for developers, that's extremely exciting, right? The idea that they can be productive in an environment that they know, and then reach all of these different kinds of audiences or form factors.
And imagine if we're not talking to an audience that knows everything about the technology, if we were talking to a broad audience and they were to say, okay, here's my iPhone, tell me what's wrong with my iPhone. Why should I get rid of this and go to Mr. Shuttleworth's baby?
So an iPhone user is not our target audience because there's a level of emotional connection to the Apple ecosystem, which I think they've earned. I think Apple has earned that emotional connection that people have to iOS and the Apple ecosystem. We don't see the same emotional connection to other platforms. And so the question is, can we create something that people will have an emotional connection to? And to do that, I think, so if you look at the non-iPhone audience, then I think you say, all right, well, today you're carrying around, look at you, 2 brains, 3 if you count your own, right?
Right.
You're carrying that around. Do you have a laptop, or are you traveling?
I have a laptop at the hotel, yeah.
Look at that. But what if you could have just one? You've only paid for that brain once, and the others are just pieces of glass.
Yeah, right. Let me challenge you on that. I would like to just have one gadget. I think everybody would, and I wish it could be this. But this is easy to carry, but visually, it's too small. I like to have this when I'm sitting up here on
exactly
stage.
Right.
So when are you going to give me a hologram that beams up and gives me a big screen? That's what we want, right?
Not a hologram, but you are seeing projectors. So you can carry a little projector around, yeah. So we're seeing all sorts of innovation around this idea. We launched a Kickstarter crowdfunding program to try to make the first device that could be a PC and things. And it failed spectacularly, but also succeeded spectacularly. It broke the record for the amount raised in a month, and it broke the record for the amount that it missed its goal by in a month. So 2 records for the price of one. But what was interesting is 20,000 people came out and said, wow, that's very interesting. We want to have that device. And since that Kickstarter, we've seen a number of manufacturers come out and say, we thought that was super interesting. It told us a lot about what people are interested in. So we're starting to make devices that can live up to that dream, to that vision. So yes, you don't want to do your email all day long on a phone screen. It's great to be able to do one email or quick reply, yes, no, on a phone screen. Right? There's a great story about executives. Executives love doing email on a phone because their emails consist of yes, no, and maybe, right? So that's easy on a phone. If you actually have to do work, not going to happen, right? Then you'll carry something more. But what do you really need? You need the brain, and then you need access to the right form factor, right? And look around you. How many screens are there here? If it was really cheap to provide those screens, wouldn't you start to get comfortable that on every plane, the screens will just be there? In every hotel, the screens will just be there. If you have to, you can reach in and grab your glass. How much lighter would that tablet be if it was just the battery and the display, and that's it? And the answer is it would be much lighter and much cheaper, much more disposable, much more reusable. So it's not that you don't want to be able to type or use a mouse or use a bigger screen or a smaller screen. That's not what we're saying. What we're saying is that it's unnecessary for you to have to keep all of those devices in sync with each other, because you could have just one brain for all of them.
What's your phone going to cost?
Oh, ours will come out in the mid-high range, so $200 to $400 devices. We're going for the high end because we want people who are looking for a very sharp, beautiful experience, and because our ambition is to be selling the future PC, the future personal computing engine, essentially, and to support our partners in doing that.
And, I mean, this is very disruptive. I mean, do you have Android and iOS scared? Are they shaking in their boots?
I doubt that.
Or do you even think they're taking note of what you're doing?
I certainly think they are, and I think we have a healthy line of communication, certainly the Android community, because it's relatively open. And the Google guys are relatively open in their thinking too, and I think at some level everybody knows that platforms serve a purpose, and then that purpose is served in a better way by something else. Android has really served its purpose, for sure. But perhaps, just perhaps, it's time for something new. And if you really look at the heart of Google's business models, I don't think they totally depend on Android, right? They depend on having great services. And so we're an open platform to integrate services into. That, of course, is very attractive to everybody who's not Google, but it doesn't mean it's not attractive to Google as well.
Anyone in the audience before we wrap up? We got one right here, this gentleman right here. Microphone. Liebe Studenten, ganz hinten, habt ihr ein Mikrofon? Ja, schön. Ein bisschen aufwachen.
Hello.
Hey.
So you talked about the Ubuntu Edge. Thank you very much, and giving us the idea, saying I will have one device, and this device will be used as telephone, will be used as tablet, and also as PC. And I suppose when I go to work or I need more power, then I connect it to the cloud, and also the cloud or whatever, it can be just a USB stick that's the backup of this hardware. Is that the main idea?
Yes, very much so.
Thank you very much. And thank you for challenging it on Ubuntu Edge, because it was a great pleasure to be there.
Thank you for supporting it if you did. Yes.
We've got a couple of tweets here. We've got a lot here now. What advice would you give to an industry leader like Mark Zuckerberg? Do you think he wants advice from anybody?
No, I doubt he wants advice from me. And, the worst kind of vice is advice. But I do think that the great privilege and burden of people thrust into that kind of position is the obligation to think 10 years ahead, which is extremely challenging. It's between us, even a guy monkey like me can look 2-3 years ahead, and we can say, well, that screen could be bigger, it could be lighter, it could have more displays, maybe it's got more dimensions to it. What's really hard is to look 10 years ahead. And I think it's also really, really fun. So I think that the real challenge is always to be able to maintain enough mental capacity outside of what's urgent today to look 10 years ahead. And that's why, for me, I'm quite happy to be wrong for 6 or 7 years about the convergence story, right? But the fact that we're already seeing things that tease at the edges of that suggests to me that it's not even 10 years away.
Final question, space travel. When do you foresee going into orbit, let's say going around the Earth one time, being affordable for the masses? Or let's say, can you imagine a time, give me a timeline, when it would cost, let's say, $1,000 to go around the Earth once in orbit?
You need quite a few laws of physics to be stood on their head before we can do it for $1,000. Either that, or you need some severe deflation. Just to put orbit into perspective, the space tourist flights that are being advertised today, which will happen in the next couple of years for sure, and they'll be fun and they'll be deadly.
But it's still prohibitively expensive.
Those suborbital flights, $200,000,
yeah.
say, $250,000.
Okay.
Those require about 1/60th of the energy of an orbital launch. In
Okay.
other words, to get you from the kind of parabola, 3 minutes, 5 minutes in weightlessness, to get you from that to an orbit is a factor of 60 in energy. But of course, it can't be a factor of 60 in weight. Or if it is, you're burning up a giant piece of equipment. To get to $1,000, we'd have to reroute our understanding of gravity. I don't think there's economically a way that we can do.
In this century, you're saying?
Well, you never know with science, right? There's a really interesting experiment happening right now, not far from us at CERN, where they are looking at antimatter. You all know antimatter, right? We've had antimatter seen antimatter for 100 years. We don't know if antimatter falls down or falls up. Think about it, isn't that fantastic? In other words, if this was antimatter and I let it go, right, first bad idea for Europe, but if that was antimatter and I let it go, the question is, would it fall up or would it fall down? And we don't know. We absolutely don't know. There's nothing in our laws of physics that says it has to be one way or the other, and we've never actually looked, right, because it's quite hard. So that is, for me, the most interesting bit of physics being done right now, because if antimatter falls up, well then, maybe we're starting to get the first sign of being able to harness gravity. And if we can reshape gravity, well then rockets will be a very smelly, old-fashioned way of getting into space. Right?
And also, it means planes wouldn't have to necessarily crash or disappear.
Every aspect of transport
in Malaysia, for example,
would be transformed. So that's why.
Okay.
That's why. There's a profound and potentially game-changing.
Yeah, I mean, we're going to
to
close with that. I don't think I've ever been at a high-tech show before and ended a discussion talking about antimatter. So, Mr. Shuttleworth, thank you for bringing something new to our discussion today. Thank you very much.
Thank you.
Great. Yep. That's going to wrap up our program for today. We will see you tomorrow. We've got a lot of very exciting panel discussions tomorrow, so we'll look forward to see you tomorrow morning. Bye-bye.
That was great fun. Thank you.